So Isha, let's talk about finding the volume of a cone using integration. So do you remember what's the formula for the volume of a cone?
Mm, is it pi r square h over 3?
Yeah, that's right. So let's write that down. Volume is equal to pi r square h over 3. Now here's a cone in the diagram, and let us denote x as the height of this cone and y as the radius of the cone, right? So any guess what should be the volume in this case?
The volume would be pi y square x over 3 here.
Yeah, that's right. So it's pi y square x over 3. Now, any idea how to use integrals to arrive at this volume?
Mm, I think if we take the slices of circles vertically and add up their areas, then we get the volume.
That's perfect. You got it. So there are circles here, 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 and in fact all through the cone. If you can just imagine packed circles,
Hmm.
right? And if you just
Right.
find the areas of each of them and add all of them up, you basically get the volume of the cone, right? So in this case, let's see how do we go about it. So here, if I were to take a random circle, let me denote this as the random circle, right? And this is my radius, small y. I'll denote the height as small x just to distinguish it from the capital X and a capital Y, right? So what's the area of a circle? The area of this circle will be pi y square, right? But if I want to integrate it over x, I want to find an expression for y in terms of x. And from properties of triangles, I know that this small triangle, right? So there is this triangle over here, right? And this bigger triangle are related to each other, right? And so y over x is equal to capital Y over capital X, right? In other words, y is equal to capital Y by capital X into small x. So what do I now do? I integrate it, right? So here is 0 and this is my x. So I integrate this area over the limits over the interval 0 to x pi y square, or 0 to x pi, let me do the substitution, y by x into x the whole square. And so that gives me what does that give me? That gives me the integral of 0 to x pi y square x square and small x square dx, right? By the way, there's got to be this dx all over, right? And therefore this is the integral over 0 to x, and I'm going to get out the constants. The constants are pi y square x square, these are all constants, and I just got this term x square dx. So what is this now? This is pi y square x square, and the integral of x square is what? it is x cube by 3, right? Now if I were to take the integral of this would be pi y square x cube by x, and so I rewrite that as pi y square x over 3, right? Which is the same as what we got here, right? This is the same as
Oh,
this,
oh yes.
right? Isn't that neat?
Yes, that is.